Myself, Dr. Dayanand Raje from Rajarshi, Shahu, Mahavidyalya, Latur, belongs from the Physics and Electronics department. Now, we will see what are the types of nuclear forces within the atomic nucleus and what are the assumptions for the liquid drop model of the atomic nucleus. In the atom, as you know, there is central hard core and dense nucleus, and whole mass of the atom is concentrated in the nucleus. Why it is called as whole mass of the atom is concentrated in the nucleus? Because protons and neutrons are more and more heavier than the electrons which are revolving around the nucleus, and each proton have a mass 1836 times more than the mass of the electron, and mass of the neutron is heavier than the proton. So it is considered that whole mass of the atom is concentrated in the nucleus. Now, within the nucleus, as you know, that there are protons and neutrons. Proton carries positive charge, neutron as a chargeless particle within the nucleus, and there is a force of attraction between proton and neutron and proton. In spite of the electrostatic forces, there is a force of attraction within a certain limit, and that limit is 10 raised to minus 15 meter, which we can call it as the 1 femtometer. Now, positive charge particles means positive charge particles means the protons, and protons carries positive charge. It means proton repels each other. But within that particular short range, that is the 10 raised to minus 15 meter, there is a force of attraction in spite of the force of repulsion. The strong nuclear force overcomes repulsion between these protons, and to hold the atomic nucleus, which binds the atomic nucleus strongly. Without the strong nuclear force, complex nuclei cannot be formed. It means there is the very strongest force in the nature or in the universe. Nature of nuclear forces. As I have explained in a previous slide, that nuclear force which are the attractive in nature and strong enough to overcome the electrostatic force of repulsion between the two protons. The nuclear forces which holds the neutrons and protons, separately we can call it as the nucleons. With the nucleon, proton means the nucleon, neutron means the nucleon, because they present within the nucleus, so they are called as the nucleons. The nuclear forces which hold the neutrons and protons together, which forms the atomic nucleus. And the nuclear forces are complex in nature and difficult to understand. It is a very difficult task to break up the atomic nucleus. And the nuclear forces are very strong attractive forces which bind the nucleons together in the atomic nucleus of the atom. These are the very strong forces in the nature, as we have studied. These forces are neither gravitational nor electrostatic. Neither gravitational means gravitational forces, as you know, that the two bodies attract each other, and the force of attraction between them is directly proportional to mass of these two bodies and inversely proportional to the square of the distance between them, according to the Newton's law of gravitation. And electrostatic, Coulomb electrostatic force, as you know, that is the like forces repels each other, and unlike charges attracts each other. It means there is the another point we can discuss in detail also. Nuclear forces are of the three types. It means the forces between two protons, forces between protons, forces between two neutrons, forces between proton and neutron, and all of these forces are attractive and are of the same order. It means the force of attraction between these two nucleons is the same. Proton-neutron, neutron-neutron, and proton-proton. Now, hence we can say that these forces are very strong attractive forces within the short range, that is the 10 raised to minus 15 meter. And these forces are independent of charges, as you have discussed in the slide, that the forces are independent of charges, means there is no gravitational force, no electrostatic force within that particular range. And this effect is called the saturation of the nuclear forces, which can call it as the saturation property also. Yakwa in 1935 gave an exchange theory of nuclear forces. It was supposed that the production of pi mesons, or particularly we can call it as the mesons, mesons are produced by the force of attraction between these nucleons. And let m naught be the rest mass of the pions, or we can call it as the pi mesons. And the rest energy we can calculate according to the Einstein's mass energy relation, that is the delta E is equal to m naught c square, where m naught is the rest mass and c is the velocity of the light. As you know, the Heisenberg's uncertainty principle, by using this Heisenberg's uncertainty principle, we can calculate the time required to exchange pi mesons between the nucleons cannot exceed within a particular time interval, for which we can write the uncertainty equation as the rest energy of pi mesons, time required for the production of pi mesons is always greater than or equal to h upon 2 pi, where h is the Planck's constant. And according to his theory, a pion is continuously exchanged between the two nucleons, means between the pp, between nn, between pn, we can say that. When they are at a distance less than about 2 femtometer, 1 femtometer is nothing but 10 raised to minus 15 meter. 2 femtometer means the diameter of the nucleus. This type of force is known as the exchange force. Why it is called as the exchange force? Because between the very strong attractive force between the nucleons, and there is a production of pi mesons due to the force of attraction between them, and there is the exchange of the pi mesons. Dr. Kalekar derived the semi-empirical binding energy formula by considering the liquid drop and the atomic nucleus. He compared what are the similarities between the atomic nucleus and the liquid drop. Firstly, Bohr and Kalekar in 1937, and after that Weizsäcker developed the binding energy formula, semi-empirical binding energy formula. What is the semi-empirical? Semi-empirical means halfly depends upon the theoretical concept and partly depend upon the practical verification. That is the semi-empirical formula. The basic assumption of the liquid drop models is that each nucleons in the nucleus interact only within its nearest neighbored molecules. Like molecule in liquid, like liquid molecules, the nucleons also interact only with its nearest neighbors. Now these are the assumptions. Now first assumption, the nuclei of all elements are considered to behave like a liquid drop of incompressible liquid of very high density. Liquid drop has a particular density, likewise the nucleus has also a particular density. That depends upon the what type of element is there, what number, which number of protons are within the nucleus, and how many number of neutrons are within the nucleus. Likewise, and as a second assumption, in the equilibrium condition or in the equilibrium state, the nuclei, or we can call it the atomic nuclei, remain spherically symmetric under the action of strong attractive nuclear forces, just like a liquid drop due to the surface tension property of the liquid. What is the surface tension? It is the property of every liquid to minimize the surface area. Likewise, here nucleus also tends to minimize its surface area uh, according to the number of protons and neutrons. We can say that um, light element, medium element, heavier element, according to the heavier nucleus, uh, light nucleus, and intermediate nucleus. The nucleons of the nucleus move about within a spherical enclosure. It means in the liquid drop, the liquid molecules can move within that drop. Likewise, there is a potential barrier. There is a potential barrier in the nucleus. Number 5th, that is the binding energy per nucleon of the nucleus is a constant. Binding energy per nucleon. Binding energy per nucleon. What is the binding energy? Again, we can say that the amount of energy required to break up the nucleus into its constituent particles is known as the binding energy. Or conversely, we can say that the amount of energy required to bind the nucleons together within the nucleus in a spherical form is also called as the binding energy. The binding energy per nucleon, it means the per proton, per neutron, we can call it as, divided by binding energy per nucleon, means total binding energy divided by mass number. Now here again question arises here, what is the mass number and what is the atomic number? Mass number means the mass of each nucleon, the sum of masses of each nucleon. That is the sum of masses of atomic nucleons. That is nothing but the mass number. And atomic number means the how many number of nucleons are present within the nucleus. That is the atomic number. Here, the binding energy per nucleon of a nucleus is constant, just like the latent heat of vaporization of the liquid. Latent heat of vaporization of a liquid. Likewise, here the binding energy per nucleon. It is the 5th assumption, 5th comparison between the liquid drop model and the atomic nucleus. Now the last, and that is when a small drop of liquid is allowed to oscillate. If we take that small drop in a dropper, which is at the end of the end point of that dropper, and if we oscillate that drop, then drop breaks. Firstly breaks into 2 or 3 other drops, small size, nearly equal 2 or 3 drops. Likewise, when a small drop of liquid is allowed to oscillate, it breaks up into 2 smaller drops of nearly equal size, and the process of nuclear fission is also similar. Nuclear fission is the breaking up of the heavy nucleus into its 2 nearly equal fragments is nothing but the fission. Likewise, liquid drop breaks. Likewise, liquid drop breaks. It means there is a comparison of nuclear fission and the breakup of the nucleus here. Now, what are the main achievements of the liquid drop model? The main achievement, it explains binding energy of large number of nuclei. It explains the fusion and fission process nicely. We have explained fission process. Again, we can say that fusion. 2 light nuclei combines together. That is the fusion, nuclear fusion. Likewise, 2 nearly equal drop combines together. It forms the large drop. That is the fusion of the atomic, fusion of the molecules. It explains the energies of radioactive decays, fission and fusion. It means the liquid drop model also explains the energies of radioactive decays. As what is radioactive decay? In the nature, there are some elements which are heavier than mass number of 200, I think 206. They are heavier. Why they are heavier? Because as compared to the protons, neutron numbers are more. Neutron numbers are more. Then that heavier elements. In the nature, heavier elements like radium, thorium, uranium, they emit alpha, beta, gamma particles spontaneously, and the life of that elements is more, and the energies emits when alpha particle emits, when beta particle emits, when gamma particle emits, there is a release of energies. Means it liquid drop model explains the energies are like of that of the radioactive decays in the fission and fusion process. Now, if we consider the water drop, particular liquid water, now we can study very large nuclei breakup, nuclear fission process and nuclear fusion process. Very small nuclei fuse together, there is a fusion of larger nuclei. When very large nucleus or heavier nucleus breakups into two nearly equal fragments, that is the nuclear fission. Now, these are the applications of the main achievements of, but there are some limitations in the liquid drop model. The liquid drop model is not successful in describing the low-lying excited states of the nucleus because of the collective motions of the large number of nucleons. Which means as the electron revolves around the nucleus, likewise each nucleon moves within the nucleus in a certain orbits also. And each nucleon has also the spin 1/2. It means this is nucleons, protons and neutrons are fermions. The particles which have the spin 1/2, they are called as the fermions. Now, according to his direction, up or down, its value is plus or minus. But actually, these energy levels are found to be quite widely spaced. If we see the energy level diagram, then the spacing between the spectral lines is widely spaced, and it cannot be explained by the liquid drop model. This is the limitation of liquid drop model. So, another models are also invented, and we can further study the another liquid drop model, that is the shell model of the atomic nucleus, Fermi model, collective model, independent model, etc., etc. Now, by using the concept of assumptions, or we can say that the concepts of the liquid drop model given by the Kalekar, say Weizsäcker derived the semi-empirical formula to calculate the binding energy of that particular nucleus. As you know, the mass number A is nothing but the mass, total sum of mass of the total nucleons within the nucleus. It means containing Z number of protons and N number of neutrons combinedly are called as the nucleons. The total number of nucleons is nothing but the mass number. It is written as a binding energy. Now, these are the terms given by the Weizsäckers. A, B, A, here is a small d, here is a small d, here is a delta. What is the first term? It means binding energy is composed of number of terms. It requires the number of terms to study the binding energy of the atomic nucleus. First term is the volume energy. Second term, the surface energy. Third term, the Coulomb energy. Fourth term, the asymmetry energy. And the fifth term is the pairing energy. Now, here small a, small b, small c, small d are the constant. Which constants are there? A is the proportionality constant, because binding first binding energy depends upon the mass number or volume energy. Second term, surface energy. Third term, Coulomb energy. Fourth term, asymmetry energy. Fifth term, pairing energy. And these are the constants for the respective terms. And he derived the particular formula. How they derived, we can see the applications of semi-empirical formula for alpha decay in the next lecture. Thank you.